All right, so ladies and gentlemen, we got chapter 11.1, day 2 notes. Today we're going to do 3 variables, 3 equations. Okay, I call these 3 by 3s. So that's goal number 4, solve systems of equations containing 3 variables, also known as 3 by 3s. The other day we did 2 by 2s. So here's 2 examples. Does anybody need to see example 1 or 2 done? Would anybody like to see substitution or elimination again? Anybody? Are we good? Speak now or forever hold your peace. So give me a thumb on where we're at with 2 by 2s. Thumbs up. So thumbs up means move on. All right, I don't see any thumbs down. If you see if I don't see your thumb down, say something. Looks like thumbs are up. So let's move on to 3 by 3s if that's okay with you. We have our 3 different scenarios here, y'all. All right, when I take a look, we have our 2 consistent systems, and we're no longer dealing with lines. We're thinking 3-dimensional. We're thinking planes. Okay, so when we talk a lot about planes, I'm think of like pieces of paper 3-dimensionally. Okay, think of walls, ceilings, floors. You're trying to find out where the wall, the 2 walls and the ceiling have in common. Okay, so visually that's what's going on. If I have 3 planes here and they intersect at one point, then we have a consistent system with one solution. And typically we have alphabetically X, Y, Z. Okay. You might be dealing with variables A, B, C. So again, it's always alphabetical. Okay, Q, R, S, or what have you. All right. If you have 3 systems, 3 planes that are intersecting, sometimes those all intersect at a straight line. Okay, so your answer might be something like y equals mx plus b. So they might have a line in common. That's a consistent system of infinite number of solutions, or IMS. And last but not least, you guys, kind of like when we had parallel lines, you might have parallel planes, okay, where there's no solution. So these planes have nothing in common. The other scenario visually that I could think of is if you have a plane intersecting a plane, intersecting another plane like this. There's nothing in common there, okay? Or if you have a triangle, I know my drawings are not the best in the world. So you could have something like this. You could have a triangle where you have 3 pieces of paper that are in the shape of a triangle. So you have a few different scenarios here. This one looks terrible, but that's the idea. All right, so we're going to do this algebraically, but this is kind of the visual concept. I'm going to use 3 different colors here. So example 1, I've got in black, I've got x plus 2y plus z equals 9. In blue, I've got 3y minus z equals -1. And then last but not least, example 1 gives me z equals 4. Well, my final answer is going to be where this thing has intersected at a point. And just so you guys know, my z looks like this. My z's and 2's look a lot alike, so I put a little slash on my z. Okay, so right now, in terms of where we're at, on example 1, we already have z. We like this one. All right, so we got to find x and y. Well, I go back and I look where I can plug in the z. If I take a look at this blue one, I've got y and z. Well, if I know z, I can find y. The idea is if I have 2 things that I don't know, and now I know one of them, plug that one thing in to find the other one. Okay, so I'm going to plug that into 3y minus z equals -1. But in z, I'm going to plug in 4. Okay, so we do plug in. We can add this guy over. Now I've got 3y equals -1 plus 4 is 3. And now I divide. We get y is 1. So I plug that guy in. And now my final answer is I got to find that x. I know I have y and z, so I go up to the equation that has 3 variables. The idea is if I know 2 of the 3, I can find the third one by plugging and chugging. Do a little pluggy, pluggy, chuggy, chuggy. So I plug in the 1 for y, and I plug in the 4 for z. And then I do a little simplifying. We got 2 times 1 is 2, plus 4 is 6, and that equals 9. And then we go ahead and subtract. So now I have x, y, and z. My final answer in alphabetical order, x, comma, y, comma, z is 3, comma, 1, comma, 4. Okay. So again, we're starting you guys off with baby steps. I've given you the 3 equations, but we gave you one of the variables. From there, I can plug in and find one of the other ones and then work my way up. Okay. Well, now in example 2, it's a little bit tougher. The first equation, I've got x plus 2y plus z equals 4. I've got all of my variables in this one. But in these two, I've got 4y minus 3z equals 1. And then the last one, I've got y plus 5z equals 6. Okay, so these last two here, the blue and the pink one, I've got 2 equations with 2 variables that are exactly the same. And as we're going through this, this is kind of where we go to. Okay, this is eventually our goal is to get to this spot where we're having 2 equations with 2 variables. If I cover this up, this is just a system of equations with 2 equations and 2 variables. That's something we did in the last section. Okay, so from here, I'm working with the blue and the pink one, and I can use substitution or elimination, but I'm telling you guys, I would avoid substitution. Because if you solve for this y, this z, or this z, oh my gosh, you're going to be dealing with fractions, some nasty fractions, okay? So I really want you guys focusing on using elimination. So I'm going to let you guys decide, what do we eliminate with the blue and the pink? Do you guys want to eliminate the blue or pink y or the z's? So do we want to eliminate y or z? What do you guys say? Suggestions. You can use your chat. You can use your, what do you got? Use your microphone. Do the y. Fantastic. Okay, so the goal with elimination, Andrew says, let's do the y. I want the numbers in front of y to be exactly the same, but one's a positive and one's a negative. So the first one in blue, the one in blue here, I've got a 4y, and the pink one is a y. Well, if I can make this a negative 4y, that's going to be perfect. Okay, so I'm going to send it through. Nothing changes for the blue one. I get 4y minus 3z equals 1. And now in the pink one, I'm going to multiply. Everything gets multiplied by a negative 4. So negative 4 times y is negative 4y. That way they'll eliminate. 5 times negative 4 is negative 20z. And 6 times 4 is 24. Okay? Now, as I'm going through, I always double check, especially when I'm multiplying with elimination, because you don't want to make a silly mistake. If you make a silly mistake here, it's going to botch up the whole thing. So somewhere in here, there's a mistake. You guys see where my little mistake is? What do you guys see? There's a tiny, tiny mistake. What did I leave out? Oh, Mr. Gotch, you dirty dog. You left out the negative, right? That should be a negative 24. All right, so don't be a dirty dog like Mr. Gotch. Okay, so double check. This guy ends up to be negative 23z, and then 1 minus 24 is negative 23. Okay, so this is really the moment of truth when you divide and you're solving for one of your variables. If you get a nasty fraction, All right, I would have got 25 over negative 23. If you get a nasty fraction, chances are somewhere there's a little arithmetic mistake or you left out a negative or something. So you should be getting nice and pretty numbers for the most part. Okay, but if you're getting a nasty fraction, oh my gosh, somewhere there's a mistake. All right. So far we got Z. Now we can go ahead and find Y. Now it doesn't matter where you plug it in, either the blue or the pink one, but you definitely want to choose one of the 2x2s. All right, so what do you think? The pink one's the easiest? Let's plug into the pink. So I've got Y plus 5Z equals 6, and we just found out that Z was 1. So we got Y plus 5 equals 6, and then we'll go ahead and subtract. So we get 1 for that. And once I know Y and Z, I should be able to plug that into the top one up there. X plus 2Y plus Z equals 4. Plug that in, and I should be able to solve for so plug in 1 for X or for Y and Z there. Do a little simplifying. 2 times 1 is 2 plus 1 is 3. And then we can go ahead and subtract. So I got X, Y, Z. Again, it's in alphabetical order. 1, 1, 1. Can't mess that up when you plug those in. Okay. Nice thing is I can plug these guys into the blue and the pink and the black and just verify that I get it to work out. And all 3 do work out. Okay. So again, it's progressively getting harder. Understand when we go on the next page, this is where we're trying to get to. We're trying to get 2 equations with 2 variables so that we can do elimination or substitution, which I recommend elimination. Okay, give me a thumb where we're at, guys. Thumb up, thumbs down. Easy peasy. You guys did this in Algebra 2, so this is nothing new. This is the second time you've seen something like this. You did not do this in Algebra 1 or Geon. So again, this is a new second time you've seen this concept. All right, so now if you take a look, oh my gosh, this is the hardest you'll see, okay? Where I have 3 equations and 3 variables. Now I have that 3 by 3 that I was talking about. I've got 3 equations, 3 variables. My goal is to get to a 2 by 2. If I can get to a 2 equation, 2 variables, okay, then I should be able to solve for X, Y, or Z. Okay. So again, this is where we want to eliminate the X's or the Y's or the Z's, and it's kind of your choice. You want to eliminate them. You want to terminate them. If you want to talk like the Terminator, yeah, you can. Okay, so I've got my 3 colors. And this is your choice. You can, if you're a guy that or gal that likes to eliminate X's, do the X's. Or if you want to eliminate the Y's, do the Y's. Or the Z's, do the Z's. It's your choice. What do you guys want to do? X's, Y's, or Z's? What do you say? X's. All right, so we're going to eliminate the X's. So I like to write that there. So I'm going to do the X's, okay? So now I understand that I got to get 2 equations with 2 variables with Y and Z, okay? So let's get started. I'm going to do the first 2. First one is 2x, the second one is x. So if I multiply this blue one by a -2, I should have a pretty nice little answer here. Okay, so I'm going to go ahead and do that. The top one stays the same. No. I've got 2x minus y plus z equals 3. And then the blue one I'm going to send through. No. That's a -2x. -2 times 3 is -6y. -2 times -2 is a 4z. because a negative times a negative is positive, and 11 times negative 2 is a negative 22. We did all that so the x's eliminate. I've got negative y minus 6y is negative 7y. I have 1z plus 4z is 5z. And 3 minus 22 is negative 18. Okay? So I always double check. Okay? You can make silly mistakes whether you're multiplying or adding down. I always double check to make sure I didn't make a silly mistake, and I don't think I did. If you see something, say something, but I think we're good so far. Okay? All right, we're like halfway to this point. Okay? So now I take a look, and I have two have-tos. I have to do two things. Okay, number one, I've eliminated the x's over here, so I got to eliminate the x's again. Okay, and I have to use the equation I haven't used yet. So I have to use the pink one, and I have to eliminate this x. And now it's your choice. Do you want to use the black or the blue one? Your choice. What do you guys want to do? What's the easiest way to eliminate this 3x?
Blue.
The blue one multiplied by what?
3.
Close, not 3, but negative 3. You guys okay with that? All right, so I'm going to send that through. I'm going to multiply the blue one here by negative 3. So negative 3 times x is negative 3x. Negative 3 times 3y is a negative 9y. Negative 3 times negative 2z is a positive 6z. And negative 3 times 11 is a negative 33. Okay, always double check. Yeah, buddy, I can multiply. Good job. The bottom one, just send it through. Nothing changes. So this pink one is just staying the same. We all did that, so the x is eliminated. This gives me a negative 11y, a 10z, and negative 32. Okay, so now we're down to these two equations. We got two variables, two equations that are exactly the same variables. Okay, so now we got to do the process of elimination one more time. So at most, you're going to do elimination 3 times. We did it once here, we did it once here, we got to do it one more time. Okay, what do you guys want to eliminate, the y's or the z's? What's the easiest? Y's or z's? What do you say? Adam, what do you want to do? Ariel, Chris, Duncan, Broderick, what do you guys want to eliminate? Y's or z's now? Yeah, so here I got a 5z and a 10z. So if I multiply this one and get a negative 10z, it's going to be easy peasy. So the number I need to multiply by here is a negative 2. So send that through. No. Negative 2 times negative 7y is a 14y positive. Negative 2 times 5 is that negative 10z, which is what we want, so they eliminate. And then negative 2 times negative 18 is 36. Okay, we did that, so these guys cancel. 14y minus 11y is 3y. And then 36 minus 32 is, what, 4? Oh, is this 19? That's right. Nobody said anything. So that's 38. So 38 minus 32. See, I knew something was wrong because, oh, man. So I got 38 minus 32, and that is negative positive 6. Nobody said anything about my mathematics here, my arithmetic. divide. And we get 2. Okay. That was the moment of truth. If I'm dividing, I had 36 minus 2. I saw it would be a 4. Well, 4 divided by 3 is not going to be very nice. I had to go double check. All right, we got y is 2. You can plug that into either one. It doesn't matter which one you plug it into. Let's plug it into this pink one here. I've got negative 11y plus 10z equals negative 32. And plugging in 2. So that gives me negative 22 plus 10z equals negative 32. I can go ahead and add that over. I've got 10z equals negative 10. And now I can divide over. Divide by 10, and I get negative 1. Questions on what I'm doing? Well, now that I got y and z, now I got to go back to the original equations, okay? Doesn't matter which one you plug it into. You can plug it into the black, blue, or pink. Which one do you guys want to do? Where do you want to plug this thing in? Blue one. Okay, so the blue one was x plus 3y minus 2z equals 11. But instead of y, I'm plugging in 2. And instead of z, I'm plugging in negative 1. Three times 2 is 6. Negative 2 times negative 1 is a positive 2. 6 plus 2 is 8, and then we can subtract. So we got x comma y comma z. We got 3 comma 2 for y, and z was negative 1. This is the second time I've done this problem today, and we solved by eliminating the y's, and we got the exact same answer. We got 3, 2, and negative 1. So again, the way you might do it might be different than how Connor solves it, which might be different than how Shayla does it. But it doesn't matter, just as long as your arithmetic is right, your algebra is good, you should be able to get the same exact answer. Okay?